This conference will now be recorded.
In yesterday's session, we were discussing about VPC. What is VPC? How to create VPC, public subnet, private subnet, route tables, all those things. In today's session, we'll try to understand about one more important service in AWS, that is ELB. We already know load balancing, right? Load balancer, reverse proxy. In real time, we'll deploy our application into multiple servers for high availability and also for distributing the load, right? We will deploy our application in multiple servers, multiple application servers, and we will make sure that application is available to the end users via that load balancer, right? If you take any three-tier architecture, three-tier application, there will be a presentation tier, there will be an application tier, there will be a database tier. So in real time, you have some application servers. Let's say this is one system. This is one system, one VM. On top of that VM, you will have some OS, some operating system. And on top of that OS, you will configure required softwares, dependencies, plus required environment to host that application. This is where we will host our application package. So in real time, we will host the same application in multiple servers. To avoid the single point of failure, we will host same application in multiple servers, and we will distribute the traffic, we will distribute the load to this application servers via something called reverse proxy. This reverse proxy is nothing but that load balancer. So end users, end customers, the request goes to this load balancer. This load balancer will forward the request. It will distribute the request, or it will distribute the traffic. It will forward that request to these applications servers where our application is actually hosted. And if you take any typical dynamic web applications, you have a GUI, that is presentation tier, and that GUI may talk to the API, that is application tier, and maybe internally it may talk to the data tier, that is database servers, right? So these application servers may talk to the database servers internally for persisting and retrieving the data. So this is where maybe you may have a GUI code, that UI code, as well as maybe required APIs also. If you take a dynamic web application, this application code may contain GUI as well as maybe APIs also, like that. Now this is any typical three-tier architecture. It may work like this. Now we will deploy our application in multiple servers, and we will make that applications available or accessible to the end users, end customers, via this load balancer. Now in case of AWS, right, in case of AWS, instead of you set up this load balancer, instead of you manage the load balancer, availability, scalability of that load balancing, in AWS there is one service. that is ELB. So instead of you manage the availability, scalability of this load balancing, there is one service called ELB in AWS. It's a managed load balancer. It's a managed load balancer. I hope you guys are already familiar with load balancer, right? So what do you mean by load balancer? That reverse proxy. So in AWS, there is one service. It's a managed load balancer. Instead of we set up the load balancer instance and we manage the load balancing instances, availability, scalability, AWS will manage for us. That is basically ELB. So ELB has some concepts again. ELB has some concepts. There are different types of load balancers again. This elastic load balancer, ELB full form is elastic load balancer. And again, there are some types of load balancers. There are some types of load balancers. So if you understand ELB, what actually ELB does, it will distribute ELB, elastic load balancing, automatically distributes incoming application request. Whatever is request is coming to that ELB, it will distribute that request to the multiple targets. The targets are nothing but your application instances where you have hosted your application. So load balancer is generally used to route incoming request to the multiple EC2 instances. Now this ELB is basically a managed load balancer. This ELB will distribute application request across multiple targets in a different availability zones within a same region. ELB is a regional level service. ELB is a regional level service. What does it mean basically? ELB will route the request to the multiple targets, that EC2 instances, but that EC2 instances has to be there in a same region. It can be in a different availability zone, but same region, in whatever region you have a ELB created. This load balancer has some family categories. Again, we have something called network load balancer. We have something called application load balancer. There is something called classic load balancer. Based on the layers, at what layer load balancer is configured, based on that they have classified this into network load balancer, application load balancer, and classic load balancer. So if you understand, there is something called OSI model, OSI layers. There are 7 layers in which the protocols, a set of protocols or layers. There are 7 layers in the OSI model. The systems will use this OSI layers for communication. Anyone, what are the layers? If you guys remember, there are 7 layers in OSI model. There is something called OSI model or OSI layers. OSI stands for Open Systems Interconnection. Open Systems Interconnection. It's a model. Open System Interconnections. It's a model. The layers, there are 7 layers in the OSI. So any components, computers or any computing devices will exchange the information using these protocols or layers. So Open System Interconnection. OSI stands for. There are 7 layers here. Based on the layer on which the load balancing is configured is categorized into this network or application like this. There are 7 layers. The first layer is basically physical layer. From top to above, I can say something like this: physical layer, data link layer, network layer, transport layer, and here On top of transport, you have a session layer. On top of session layer, you have a presentation layer, application layer. So this we call it as a layer 7 application layer. We can configure the advanced routing. If you guys are using application layer, right, you can configure advanced routing mechanisms here in the application layer. Using layer 7 load balancer, you can define very advanced routing like host based routing, path based routing, like that. So that load balancer works at request level. And this is layer 4, transport layer. Transport layer, layer 4. This is heart of the OSI layers. So this is at a connection level. So when we guys configured the load balancer at layer 4, that is at a network level, connection level, the load balancer cannot intercept the request. The load balancer cannot intercept the request, and it cannot see what request is coming with what headers, what path, what data. It cannot intercept. Just a request will come to the load balancer. It will just forward that request to some other IP at some port, at other some IP at some port, but it cannot intercept the request to do the different advanced routings. But when it comes to layer 7 load balancer, that is application layer, this application layer load balancer works at the request level. We can have advanced routing features. We can intercept the request headers, path, the body, based on the headers, based on the path. Also, we can do the routing to the different applications. So this network load balancer is a layer 7 load balancer. This application load balancer is a layer 7 load balancer. This classic is basically at both. You can configure at layer 4, but this is legacy, very old load balancer type, and layer 7 also. So layer 7, layer 4 works on TCP or UDP protocol. This layer 7 HTTP or HTTPS. You can define the advanced routings in the application load balancer. Sometimes in the interviews also they're asking, if you guys are attending some general DevOps interviews or some AWS interviews, if you guys are attending, they may ask what is network load balancer, what is application load balancer, or layer 4, layer 7 load balancer. So is everyone clear? What do you mean by these OSI layers? There are 7 layers. This network load balancer works at a transport layer, at a connection level. It will just receive the request and it will just forward the request to some set of IPs and ports, but it cannot intercept the request data. We can't define advanced routing mechanisms like path-based routing, host-based routing in layer 4, but layer 7, that is possible. So AWS ELB also has a like layer 7 load balancer, that is application, layer 4 load balancer at a TCP port, and this is previous legacy. It supports both. As I already told, network load balancer operates at the connection level. Network load balancer works at the connection level, layer 4. It will route the request, whatever request comes to that NLB, network load balancer, it will route the request to some targets, some EC2 instances. So it will route the connections based on the IP protocol at layer 4. Based on some IP protocol, it will just forward the request to some set of IPs on some port. But it cannot intercept the request. It cannot intercept the request. And you can't define advanced routing features at the request level, host-based, path-based in the NLB. So this network load balancer supports TCP and UDP protocols. It is capable, this network load balancer is capable of handling millions of requests per second. It is capable of handling millions of requests per second while maintaining very low latencies. And again, this is optimized for handling sudden or volatile traffic patterns. So it will just receive the request and it will just forward the request to some IP address on some ports, but it cannot intercept the request. So let me demonstrate network load balancer. Let me deploy some sample application. Let me deploy some sample application. Let me deploy some sample application into, let me first deploy some application in my servers so that I can make those applications accessible via load balancer. Guys, I am going to follow the typical VPC architecture. If you guys remember, yesterday we created one VPC. If you guys remember, yesterday we created one VPC. That VPC has some subnets. That VPC has some subnets. How many subnets I have created in total in that VPC? I have created total 4 subnets. 4 subnets. Let me total 4 subnets I have created. In one of the availability zone, I created one public subnet and one private subnet. So here I have created one private subnet and I have created one public subnet like this. Now similarly, I created one more availability zone in that region. Again, I created one public subnet, one private subnet. So in real time, as I already told, we will deploy our applications in private subnets only. So what I will do, I'll create some EC2 instance to host my application. I'll create some EC2 instance to host my application. In private subnet only I will host. I'll create some EC2 instance like this. In a private subnet only I'll host like this. Maybe let's take any application. That can be any application, guys. That can be Java based application, that can be Python based application, that can be any Node.js based application. You can take any application. So I'm taking this application. It's a Java based web application. Typically, people demonstrate with the normal HTTP web server this load balancing, but typically we will use load balancing to load balance your dynamic applications. So I am going to take this dynamic web application only, developed using Java, and deploy this application. First, let me create a servers. In which I will deploy this. First of all, this is Java based application. I need to build a package. A kind of a var file. I hope you guys are familiar with the Java based applications, right? As a developer, developers will develop the application code, but as a DevOps engineer, we need to understand what programmatic language they used, how to build and deploy that applications. So you need to know all these things. Developers can develop maybe Java applications, Python applications, or Node.js applications, or Ruby and Rail, or React and Angular, any type of application. But you should know how to build and apply that application. So this is one Java based application. Let me build. So what I will do, I will take one normal server for building. Let me take maybe one normal server. I am going to manually build that application. Let's say I have already one server here. Right? So let me get that code here and let me manually build and copy that code to this servers. First, let me go to that server. We already have one public server, right? We already created in that VPC. Yesterday we created one VPC, the demo VPC. I think I have stopped those servers. Let me start. Yesterday we created one demo VPC. In that VPC we created some servers, right? I stopped that servers. Let me start. So I already have one server in the public subnet. I already have one server in that public subnet. Let me connect to that server where I will get the code and I'll compile the code and I'll create a package. I'll get the code, I'll compile the code and I'll create a package. Let me see this server. If you see, this server is created in this demo VPC. It is there in a public subnet. So let me SSH directly from my laptop to this server. Let me SSH to that server. So this is kind of a public server. Now let me get this code. Let me get this code. I'm manually building this application. So I got a code. Let me go inside that code. I'm executing maven command and I don't have a maven in this server. If I execute maven command, it will give error. Maven command not found. So Java is also not there. Maven also not there. We need a Java, JDK and Maven for building the Java based applications. So let me install using package manager only. I'm installing Maven. Maven internally depends on Java, so it will install Java also. Both are getting installed in this system. So I'm installing build tools like Java tool, Maven tool in another server where I'm just building the application. Later, I'll create an servers for deploying that application. For now, in my one of the build server, I'm building that code. Later, I will create some deployment servers, that application servers, where I will host that application. Now you can see Maven is there, Java also there. Now this command works. Let me create a package. It will take some time. Maven concept you need to understand. Maven is downloading the required dependencies from central repository to local repository. It will take some time. Now the build is successful and I can see the Java package, that web application package is generated. So I just created a, in this server I have built that package basically manually. I got the code, I built this package here in this server. I built that package. Now I'll create some servers in these subnets, kind of a private server where I will host this application. So I already have one private server. Let me use that private server. So if you guys remember, yesterday we created one server in that same network, demo VPC. in a private subnet, right? I already have one server. This is private server. I can't SSH directly from my system, directly from my local laptop. So let me do this. Let me SSH to that jump box first. Let me SSH to the jump box, that public server. This basically public server. So in that VPC, I have one public server. Let me SSH to that public server. In another tab, I'm SSHing to that. From here, let me SSH to that private server, because I need to install required softwares to deploy that application. It's a WAR file, right? But first I need to install required softwares like Java and Tomcat, required softwares like Java and Tomcat to deploy that application in this private server. So let me SSH to that private server from Jumpbox. Here I will execute some script. I'm going to install Java, I'm going to install Tomcat, and I'm going to start the Tomcat. So I'm running some script here in this private server to install Java and Tomcat. And Tomcat also started. But my application is not deployed. My application is still not deployed. Here, this is my application server. I installed Java now. I installed Tomcat. And I have started Tomcat, but the application is not deployed. So I will SCP from this server. I will SCP that into this server. So I have that WAR file in this server. From this server, I will SCP to this server. Now, still installation is going on. Let's wait. Installation is still going on. Now you can see Tomcat is started in this private server. But let me come to this jump box, this kind of a public server. I have to copy this code there. I will use SCP command. And I need a PEM file for SCP also that I have in this server already. Then this WAR file I have to copy to that server ec2-user @ that private server IP. And I have installed Tomcat in OPT folder, Tomcat 8 under web apps. We need to copy. You guys familiar with Tomcat and all those things, right? So I'm just copying that code to this private server where Tomcat is installed and started. Now, since Tomcat is installed and already started here, now that application is up and running. You can see in this system, this is that actual private server. Now under web apps folder, I copied, right, from that. Now you can see application is hosted. Here. Like this, let's say in real time, as I already told, we are going to deploy application into multiple servers. For what reason we will deploy same application in multiple servers? For what reason we will deploy that application into multiple servers? Basically, if my application is hosted in a single server, right, if something goes wrong with that server, or maybe something goes wrong with maybe application or maybe server, or maybe there might be a network failure, or there might be a OS failure, or there might be an application failure. Do you have any other process available for your end users to serve the request? If you have only single server where your application is running, if that has some issues, do you have any other location where your application is running and it will serve your customers? No. So it is like a single point of failure to achieve high availability. And again, even though your server is running, if there is a lot of load, all the requests will go to same server. Will it able to handle lot of requests by a single server again? No. So you need to distribute your load. You need to avoid single point of failure. That's why we will deploy same application in multiple server. So let me create one more server. I will deploy the same application there also. Let me create one more server. Let me create one more server. Again, it's kind of a private server only. Again, it's kind of a private server only. Maybe in another availability zone, private subnet only. In real time, we will deploy in a private subnet only. So let me select the network, that demo VPC, Under the demo VPC, I'll create this in another private subnet. And I don't want to waste much time here. I want to install Java and Tomcat while creating a server itself. Can I use this user data concept? I'll just keep this script here. It will just install Java. It will just install Tomcat, extract, and start Tomcat, user data concept. But again, Tomcat is going to run on port 8080. So let me open that port also in this server. I'll open that port in one more server also, whatever which is already there. I'll open there, but here let me open. For everywhere, I am opening. It is just installing Tomcat and it is just going to start the Tomcat. Okay. Guys, I'll share this installation script. I'll just share this installation script. If you really need this installation script, I can share. Guys, this is not something new which I am doing. You already know what is SSH, you already know what is SCP, what is shell script, right? I am just installing Tomcat Java in that server where I will host my application. I am not doing something new here. So I am just created a one more server. Again, one more server, kind of a private server. Again, this one. So as I used user data to host the to install the Tomcat, to install the Java and Tomcat. I used basically user data, but my application is not hosted. I'll copy that code again from this server. In this public server, I have that var file as of now. From here, I will SCP to this server also to deploy my application. Let's wait for this server to become ready. 2 by 2 checks, because it is still initializing. Once this is ready, then I will copy that code here. Now this server also become 2 by 2 checks successful. Now Tomcat I have installed and Tomcat I have started using user data. Now I'll just copy this var file. This var file, whatever I have in a target folder, this var file again I will copy to that new server using SCP command. That SCP also requires PEM file. I have that PEM file in this server home directory. This target folder, this var file, I am copying into this system, this IP. Sorry, not this IP, this IP. And here we installed the Tomcat as part of OPT web apps. I will copy that var file with this name. Basically, with this name, I am copying into this server also. Now let me type yes. Now we deployed our application. We deployed our application in both servers. So here also I have done the same. I have installed Tomcat, started Tomcat. I copied this file from here to here, here to here, which means did I done like this? As of now, did I done like this? But I don't have any application which connects to the database. But did I done like this so far on that EC2 instance? This one, I have that EC2 is nothing but a virtual machine. On top of that virtual machine, you have a OS, Red Hat. I installed required softwares like Java, Tomcat, then I copied my code. So these are private servers. This one and this one are private servers where I have hosted my application. Does end users can access this application via these private IPs? Because end users are from internet. Does end users can reach even though you have opened that ports in the security group in the firewall? Does end users can reach? You guys also one of the end user. Are you guys able to reach this application? Even though ports are open, let me open here. It is already open. Port 8080. Port 8080 is open for all the sources in this server. If you take one more server also, if you see here, port is not open, but let me open that port 8080. Are you guys able to access that application which is hosted in that private server even though application is running? No, because it's a private IP, so you don't have routes. That private IPs are not reachable or not routable in the internet. Now, but how can I make this application available or accessible for my end customers? The applications hosted in a private subnet. This is how in the real time you are going to host your applications. If you guys are using virtualized deployment, you are going to deploy like this. How can you make this application accessible for end users? By creating a load balancer. But instead of you create a load balancer, there is software load balancer you can use like Nginx. Can I create one EC2 instance if required? Can I install Nginx? Can I define the reverse proxy rules in this Nginx to route the traffic like this? Yes, but I don't want to create and manage the load balancer. I can go for ELB. That is where there is a service called ELB. It's a managed load balancer. So I can create a load balancer. In the background. Who is going to create a load balancing instances and who is going to manage the load balancing instance? If I just create a ELB in the background, who is going to create and manage the load balancing instances, the load balancing servers? AWS. AWS will create and manage the load balancing instance. Load balancer has something called a listener. Load balancer has something called listener. Listener on which port, on which protocol the load balancer will accept the request, on which port, on which load port, on which protocol the load balancer will listen the request. Each and every load balancer should have at least one listener. Each and every load balancer should have at least one listener to accept the traffic. So we have something called listener. Define the port and protocol on which the load balancer must listen. Each load balancer at least required one listener to accept the traffic. And you can have up to 50 listeners also, but different ports. But most of the cases, right, we will have only two listeners. One is listening on port 80, another listening on 443. Secure port 443, insecure port 80. Those are the default ports. So load balancer will have a listener. Request goes to load balancer, and that there is a listener which is going to accept the traffic on some port like this. So this listener will listen the request. What that listener will do? It will forward the request to some target group. So target group is nothing but the logical target. Target group is nothing but a logical concept. Target group is a logical grouping of your actual targets, your EC2 instances behind the load balancer. Target group is basically a logical grouping of targets behind the load balancer. So target groups can exist independently from the load balancer. Target groups can exist independently from the load balancer. And target group can contain up to 1,000 targets. The target can be EC2 instance, the target can be Lambda function, the target can be again load balancer, like that. So target group is a logical grouping of targets behind the load balancer. These target groups are used in your load balancer listener. So load balancer has a listener. That listener will accept the traffic. That listener will forward the traffic to the target group. The target group is a logical grouping of targets behind the load balancer. So let me create a target group first. It's a logical grouping of the targets. So target group can exist independently from the load balancer. So here you have something called target group. Let me go to this target group. I have these target groups for different demonstration, guys, different application. So let me create a new target group. And again, I'm going to demonstrate network load balancer. So network load balancer works at the connection level, TCP protocol. So I need to create a target group also and a TCP protocol. I am creating a target group. I am giving some name, right? AWS, some name, ELB, network load balancer, some name, network load balancer, something, network NLB, network load balancer, demo, app, one, something like this, target group. So this target group also has to be configured on TCP protocol, but this is target group port. On which port your target will accept the request, on which port your application is running. So on which port my application is running? Actually the Tomcat port, basically 8080. This is my target group port. I am creating a target group. My target type is instances, TCP protocol. This is my target port on which my application is running, 8080, and my targets are in this VPC, demo VPC. My targets are in this demo VPC, and this network load balancer performs health checks at the connection level. It is like internally it will try to check whether that port is reachable or not, whether it can connect the target on that target port or not. It will check the health check at a connection level. These are the default health checks: healthy threshold 3, unhealthy threshold 2, timeout 10, interval 30, like that. So now interval 10 in the sense every 10 seconds health check will be performed on this target on that port, kind of a connection level it will check, not application level. If it is able to connect, if the target port is able to reach, then it will considered as healthy, otherwise unhealthy. So load balancer will use these health checks. Load balancer will use these health checks to shift the traffic away from the failure instances. Load balancer will use these health checks. If load balancer is able to find one instance is unhealthy, load balancer will stop sending the request to that unhealthy instance in the target group. So load balancer will internally use health checks. Network load balancer also perform the health checks, but connection level. So these are the health checks. Let me click on next. Now you need to select your servers, your targets. You can register your targets into this target group. So let me select these two servers where I have hosted my application, where Tomcat is hosted and where my application is copied in these two servers. Select these two. Click on include as pending below and create a target group. Create a target group. Now this target group I can use in my load balancer. So let me go to load balancer. I'll create one load balancer for this application. Let me go to load balancer. I have a lot of other load balancers, but this is for different application I have created. But let me create a load balancer. I'm going to create a network load balancer. Let me give some name, ELB, network load balancer, demo app, something like this. And again, when it comes to load balancer, there are two things, internet facing load balancer and internal load balancer. So if now I want to access this application from internet, my end users are from internet, they are not part of the same network, so they are from internet. So I need to create a load balancing, the scheme internet facing. But if you have to create an internet facing load balancer, you need to have a two public subnets minimum. Two public subnets is required in order for you to create an internet facing load balancer, because you are creating a ELB, in the background the ELB instances will be created in the public subnets. Then only you can reach ELB, right? I mean to say end users. End users can reach ELB if the ELB is created in a public subnet only. Otherwise, end users can't reach this ELB, right? So if you have to create a internet facing load balancer, minimum two public subnets is recommended in that VPC. If you guys remember, in yesterday session, did I created a two public subnets also like this? Here one public subnet, here one more public subnet for that VPC in two different availability zones. In yesterday session, we created a VPC, right? So let me proceed. Let me select internet facing. Under which VPC? Under this demo VPC. In the same VPC where my targets are there. My load balancer also created in same VPC. And you need to select the mappings. Mappings basically two availability zones and two public subnets. This is for load balancing, okay? Make sure you guys are selecting public subnets. Whatever you are selecting here, you have to select public subnets, because in the background, this ELB will create load balancing instances in this public subnet. So minimum two public subnets is recommended in each availability zone like this. I selected public subnet. Load balancer will have a listener. This is load balancing port. Only. The default port is fine. Any request comes to this load balancer on port 80, I can take some action. What I can say, forward the request to this target group. On the target port. With this, let me create a load balancer. network load balancer. Now load balancing instance is getting created. We are getting some error. For what reason? Is it already created? Let's see. I think the session is timed out. That's why it was not able to create. Let me see. I created a target group anyhow. There is a target group. If the load balancer is not created, I'll create again. There is a target group, but this load balancer, let's see if it is created or not. It is not created. Let me create, because the request that session was timed out. Let me create quickly. I'm giving a name, something like this, internet facing. In this demo VPC, I'm going to create and select the public subnets. Minimum 2 public subnets are recommended for your load balancing instances. Let me select public subnets in these two. Any request comes to this load balancer on this listener, on this load balancing port, it will forward the request to target group on that target port. Let me create a load balancer. Now load balancer is getting created. In the background, AWS is creating a load balancing instances. The load balancer is getting created. You can see it is provisioning. It is provisioning this one. This load balancer has a listener listening on port 80 on TCP protocol. Any request comes to this load balancer on this listener, that is going to forward the request to this target group. In the target group, do I have some targets? Basically my servers in which I have hosted my application. Yes. As of now, there are two targets. As of now, there are two targets, two servers in which I have hosted my application. So the moment I use this target group with my load balancer, it is performing the health check. Currently, the health check is shown as initial. After some time, you can see whether it's a healthy or whether it's unhealthy like that. Now, let me show this load balancer. Right, load balancer is also getting created. It is going to take some time. It is still showing provisioning. Let's wait for this to become active. Let's wait for this to become active. Let me see if this load balancer is active now. It is still provisioning, in the sense, in the background, load balancing is getting created and configured. AWS is doing that. If you see, now it is still provisioning, but let's wait. It has to become active. Meantime, let me show you. This load balancer has a DNS name, some kind of a name, host name. Load balancing, it is not displaying public IP, but it has a DNS name. This name is internally resolved to IP only. If you have a NS lookup software, you can execute NS lookup on this one to see the IP. I don't have NS lookup. Let me install. This is as part of bind utils. This NS lookup software. Now, if you see this name, load balancer, we got some kind of a DNS name. This is the DNS name of the load balancer. This name is internally resolving to IPs only. This is the load balancing instance IPs. By looking at those IPs, you can easily guess, is it a public IPs or private IPs? These IPs of that load balancing, these are the load balancing IPs. Is it public or private? Come on guys, these are public IPs, right? These are public IPs, not private IPs. Public. So we told RFC 1918 range, RFC 1918 range. So if any IP in this range 10.0.0 maybe till 10.255.255.255, this is RFC 1918. In 172 also from 16.0.0 till 172.31.255.255. In this 192.168.0.0 till 192.168.255.255. These are RFC 1918 addresses. These addresses are used for private host, internal host, private host, basically private IPs. These IPs are non-routable, non-reachable in the internet. Now, this, is it a private IP or public IP? This one and this one? Public only. These are IPs of the load balancer. These are IPs of the load balancer, but who created that load balancing instances and who is managing that load balancing instances in the background? AWS. So that's why we selected public subnet. When we created ELB, internet facing ELB, that's why we selected a public subnet, that load balancing instances are created and managed by AWS in the public subnet. Now, if I access this domain, request goes to load balancer. I am not specifying any port. Internally, this domain will result to this IP or this IP. Request goes to that load balancer IP. Since I am not mentioning any port, what is the default port? Request go 80. And do I have a listener in the load balancer which is going to accept that request? Do I have a listener in that load balancer which is going to accept that request? Do I have a listener on which it is listening on port 80? This one? Yes. Then whatever request comes to this load balancer, what that listener will do? It is going to forward that request to this target group. In this target group, do have some targets? There are two targets. Two servers in which I have hosted my application. Is request goes to the target group on this target port? Is the request will go to maybe this server on this port, or maybe this server on this port where my application is hosted? Yes. If you see, I'm just accessing like this. I'm getting a Tomcat home page. Request is going to load balancer. From load balancer, it is forwarding the request to the target group on the target port. My application is not running on the root context. This is my application context. If you see, I'm getting a response from one of the server. I'm getting a response from one of the server. Is load balancer is forwarding the request to one of the server in that target group. And I have customized the code, guys. I have customized the code. So there is a Java code here. I have developed some code to print the IP address of the machine where my application is hosted. That host IP I have displayed. Host IP I have displayed because here we have a code. In this, I have a code where I customize the code. I can see the IP also. Is one of the server is processing that request. I'm getting a response from 10.0.0.108. In this target group, there are two targets. Maybe one of the server Let's see which server it is. I am getting a response from 108. Is anyone getting response from another system instead of 108? Because there are two healthy targets in that target group. There are two healthy targets in the target group. So anyone getting the response from another IP? This 251. So is everyone clear? What is load balancer? How to create a load balancer? What do you mean by listener? What do you mean by target group? How to make our applications accessible? I got the request from 106. It is not a request response, guys. You are getting a response from 108 because the server is responding to your request. So is everyone clear? What is load balancer? Basically ELB. What is listener? What is target group? How to make our applications accessible via load balancer to the customers? This is network load balancer. Any questions, any confusions here? You already know using Terraform you can create EC2 instances. Using Terraform you can create EC2 instances, right? You already know some little bit of knowledge. Similarly, using Terraform, can I create a load balancer? It's a listeners and also target groups if required. Using Terraform, yes. Using Terraform also you can create a load balancer. The way you manually created a load balancer from GUI, you can create a using Terraform also. So in Terraform, you have a AWS provider. Terraform works based on the providers. Terraform, you have a AWS provider. This provider comes with a lot of resources. AWS underscore instance. This is one of the resource, right? AWS resource. You guys created a EC2 instance, something like this, right? At least this much you already know. In Terraform, did you guys created some script like this where you specified AMI ID, what type of instance, t2.micro, something like that? You can create a EC2 instance like this. Similarly, there is a AWS ELB resource. You can create a ELB. You can create a ELB also. You can create a load balancing. So you have a load balancing resources using AWS provider. Using AWS provider, you can provision the load balancer also. You can see here ELB, right? Load balancer. Using this resource, you can define all these things, guys. You can say load balancer name, whether it's an internal load balancer or internet. Here internal value is defined as a false. Which means what type of load balancer that scheme. Since internal is defined as a false, what type of load balancing will be created? Is it a internet facing? Yes. And also what type, whether it's a network or application. And subnet. If you want to create a network load balancer, this is how you will create. So internal false, load balancer type network. Under which subnet? You need to select the public subnets, right? You are going to define all this information. So you can create a load balancer. For that load balancer, you can create a listener. You can see there is one more resource, AWS listener, and target groups you can create, and you can mention all these target groups, listeners in your load balancer. So if you know the AWS concept, learning Terraform is not rocket science. If you know the AWS concepts, learning Terraform is not a rocket science. Everything is documented. So Terraform is infrastructure as a code. So you are going to define your resources, your infrastructure resources in the form of code, declarative format. So Terraform works based on the providers concept. So there is a AWS provider, Azure provider, GCP provider. So based on what type of infrastructure you guys are using, whether you guys are using AWS infrastructure or Azure or GCP, you can use respective provider, and using respective resources, you can create a resources like this. So if you know AWS concepts, that cloud concept, basically learning Terraform is not a rocket science. But anyhow, we will discuss this later. But is everyone clear what is load balancer, how it works? But here, if I have a one more application, if I have a one more application, if I have a one more application, is it possible for me to route the request to another application via same load balancer and a same default listener? Because it cannot intercept the request, right? Based on the host, based on the path, it cannot differentiate. Based on the host, based on the path, it cannot differentiate. So in that case, you need to create a one more network load balancer, because network load balancer works at the connection level, not at the request level. It works at the connection level, not at the request level. So you cannot differentiate whether request is coming for which path. Based on the path or based on the host, you can't define the routings in the network load balancer. In that case, you have to go for a application load balancer. Otherwise, you can go with another network load balancer. Otherwise, you have to create a one more network load balancer. You create one more network load balancer. In this network load balancer, in this listener, you say forward the request to one more application target group 2, one more application. Just to give an example, there is one more application like this. You define the request to this target group. This load balancer can route the request to this target group. This load balancer can route the request to this target group where different application is hosted. So let me create one more server to host one more application, different application. Let me create a one more server, different server to host the different application. Again, I am going to take one more application. Again, one more Java based application I am taking. First, let me create a server. One more application. Let me take Red Hat as a AMI, whatever instance type as per your requirement to keep it. And again, let me create this one also in that demo VPC. And this is again in one of the private subnet. I am just creating in one of the private subnet. And here also we are going to install Tomcat and access that application. So let me open port 8080 for all the sources. Now again, I will install the Java Tomcat using user data again. I will install Java Tomcat using user data, but I am not deploying any application as of now. That application I will build and apply later. Let's create the server. Let's create the server. Meantime, server will be created. Meantime, let me get this code and build the package. So I will get this code into again that server, public server. Let me come out of this folder. I'll get this code also here. I'll clone the code here where I have a Java and the Maven also installed. Let me build this package. Let me build the package for this application. Later I will deploy this into that server, whatever server I created just. Now I got this code jar var file generated. Let's see this server is ready or not. The server which I just created to deploy this application. So this server, it is running, but let's wait for the 2 by 2 become ready, because still it is getting frozen. Let's wait for that to become ready. Later I'll copy that code to this server. But again, it's a private server in this demo VPC. In this private subnet, it is there. For different application, I created a server. Jumbox server, how to create? That is just one public server. That is just one public server. That's it. I created one instance in a public subnet. There I just SSH. From my local laptop, I can't SSH to the private server. So I just created one public, I mean to say one server in public subnet. There I SSH. From there again I am SSHing to the private subnet. That is what the Jumbox Bastion host. I hope you attended yesterday's session, right? I have not done anything. I just created one server in a public subnet and I SSH there. From there again I am SSHing to the private server. Come on, if public server is in default VPC, how do you connect to the private server in another VPC? You know networking concepts, right? By you have a public server in default VPC, but from that public server, will you able to privately connect to the private server in another VPC by default? No. So you have to create the public server in the same VPC. In demo VPC only it is created. You know networking concepts we discussed yesterday in detail. Recap or go through the recording one more time if you are not clear. If one server is in another VPC, by default is that server can talk to the another server in another VPC using private channel, private network, using private IP by default? No. If that has to happen, what you have to do? You need to do the VPC peering. Right? We discussed, right? Now, this is just one server in the same VPC, but in a public subnet. I can SSH to this server, and in this server, I am maintaining the PEM file also. From this server, if required, I can SSH to the other servers, other private servers. If required, from that server, I can SSH to the other private servers in the same VPC. That is called as a Bastion host or Jumbox. Okay, let's see if this server is ready. Now this server is ready. So let me take this IP address. From here, I will copy that PEM file also required for SCP. I will copy this file into that other system /opt/tomcat8 tomcat8/web apps. I'll just copy without 1.0. Just I'll copy as something like this into that server, deployment server. Now, 1 second, there might be a typo, web apps. So I copied. Now I deploy different application in this server. So I deployed different application in this server. So I took one more server where I have deployed different application. So I'll create a target group. I'm just demonstrating only with one server. If required, you can create multiple servers and add the servers to target group. So let me create a one more target group, new target group for that application. I'm giving name something like this, some name, something like this. And again, if I have to use with the network load balancer, it has to be on TCP and the target port 8080. In this VPC, I have the targets. If required, you can customize your health checks. Maybe continuously 3 times if it is successful, I want to consider it as healthy. If continuously 2 times if it is not successful, I want to consider it as unhealthy. And every 10 seconds it has to perform health check. I can modify these health checks settings. Now I will add only whatever server, only this server for this target group. Click on this include as pending below. Create a target group, and I can use this target group with another network load balancer, because in the existing network load balancer you cannot differentiate the request coming to which application, because network load balancer works at the connection level, not at the request level. So let me create a one more network load balancer for other application. For now I am saying something like this, some name, again internet facing. In this VPC, demo VPC, and you need to select the load balancer mappings in the, under which subnets load balancing has to be created. Make sure you guys are selecting public subnets for load balancing instances, and any request comes to this load balancer on this port, I will say forward the request to this target group, another target group, that is for other application. Now I am getting one more network load balancer. I am getting one more network load balancer. So if any request goes to this load balancer, it will forward the request to this target group. If any request goes to this load balancer on this port, TCP port 80, it will forward the request to this target group. And I have one more network load balancer for other application. If any request goes to this load balancer, one more load balancer on this port, on this listener, it will forward the request to this target group. So this you guys already able to access. We already deployed this load balancer. Via this load balancer you guys are able to access this application. But let me share another load balancer DNS name. This load balancer DNS name, it is still provisioning, but let me show you. This load balancer has its own DNS name. I already have a NS lookup software. If you see, it is resolving to different IPs, but it is still provisioning. That's why it won't work. Let's wait for some time. Let's wait for this to become active, this load balancer to become active. Later we can access the other application via this load balancer. Let's wait for that to become active. It is still provisioning. That's why it is not working. Once it is completely ready, there will be IPs assigned for this load balancer. Let's wait for that. Let's wait for this to become active. In the background, again for this load balancer, for this ELB, AWS is creating a load balancing instances and configuring that load balancing in the background. Now this is become active. Now if you see, this load balancer has its own DNS name. Let me see the NS lookup on this one. It has given some IPs. These are different IPs because this is for a different load balancer. These are different IPs. Now If you access this load balancer, request goes to another target group, and let me access my application context also. My application context is something like this: Java web app. This is different application via different load balancer. You guys are able to access. You try to access this load balancer. Are you guys able to access the other application which is configured in this load balancer listener? Request is going to this load balancer from here, this target group. As of now, this target group has only one server. If required, you can add multiple servers based on your requirement to the same target group. You can apply same application in multiple servers and you can add that into this target group. But if I use network load balancer, if I use application load balancer, is it possible for me to route the request to the multiple target groups, multiple different applications behind single application load balancer, where I can define advanced routing rules, host-based routing, path-based routing, because application load balancer works at the request level. We can intercept and define the routing at a request level. That I will demonstrate tomorrow, guys. That I will demonstrate tomorrow. So is everyone clear what is load balancing? With respect to load balancing, what is ELB? And again, within ELB, what is network load balancer? Guys, all these things, just for refreshing your AWS knowledge, I am again discussing. Just refreshing your AWS knowledge, again I am discussing. So this is nothing to do with Terraform. Terraform, whatever I am manually creating, that can be a server, that can be a security group, that can be a load balancer, or that can be a storage, whatever we are creating manually, can I provision that using Terraform? Yes, that is what infrastructure as a code. So I'm just refreshing your AWS knowledge one more time, so that when I explain Terraform, you don't have any questions or what is AMI, what is security group, what is VPC, what is subnet. You should not ask those type of questions. That's why I'm discussing all these things again. Because when I say Terraform script, right? When I show some Terraform script like this, maybe, sir, you should not ask, sir, what is that AMI? It is nothing to do with Terraform, right? That AMI security group, it is nothing to do with Terraform. That is AWS concepts. You are defining that information in a infrastructure as a code. So Terraform will internally make the required API calls to create the infrastructure. So try to practice all these things, whatever has been discussed, like create EC2 instances and explore, create a S3 buckets and explore, create EBS volumes and explore, create network VPC subnets NAT instances and explore around it, and also create a load balancer like this and play around it. When we discuss Terraform, it becomes easy, because in Terraform script, I will say AWS EC2, AMI ID, security group ID, VPC ID, like that. So that time you have a clarity what you are doing. Instead of manually creating these resources, you can do it in Terraform so that you can understand. Any questions? Any queries? Any confusions? Let me know. Otherwise, I'll stop the session here today. I'll continue tomorrow with application load balancer. Later, I will explain auto scaling group. Okay, I am considering you don't have any questions. Thank you. I'll continue tomorrow with application load balancer. Then I will explain auto scaling group, guys. Thank you. We'll continue tomorrow. But practice manually also. Go to AWS console and explore around these services manually also. GUI. We'll continue tomorrow.